Hi everyone, welcome back, and let's start with term frequency, inverse document frequency, also known as TF-IDF. So basically, in the last video we studied that back of words had its own limitations, where too much importance was given to common words or stop words such as and, the, as, etc. Right? So this kind of too much importance given to two common words was taken care by TF-IDF. You see, gradually things have started. Scientists, they find a problem and they try to solve it, and in terms of solving it they come up with something better, right? So what happened in bag of word is that if you look at these two sentences, the movie was amazing and thrilling, and you look at the movie was the best, right? What you'll see is the is occurring three times, right? So it would be in bag of word model, it would give a lot of weightage to the word the, but you and I, we know the word the will not have that much importance, right? So what TF-IDF does, it increases the importance of rare words but important words, right? And then it lowers the importance of common words. Now how it does, let's try to understand. So as I said, TF-IDF is nothing but it's made up of two components, which is term frequency, and then it is multiplied by the inverse document frequency itself, right? Now what is term frequency? It is how often a word appears in the document. It's just the count of that word appearing in a document, right? And what is inverse document frequency? It's basically a formula which tells you how rare or unique a word is across multiple documents. Let's try to understand it. Let's try to drill it deeper, right? So here you will see that the TF-IDF is basically composed of two things, is basically a multiple of two things, which is your term frequency and the inverse document frequency. As I said, term frequency is nothing but the count of the term in the documents itself, and this is the formula for inverse document frequency. Here N is nothing but number of documents, and DFT is nothing but the document frequency of the term T itself, right? By the TF-IDF score, what will happen if the words that occur more frequently in one document but they rarely occur in any other document, these kind of words will get high scores, right? So the words like the and those kind of stop words, they will automatically get a lower score. Now how TF-IDF works is exactly in this particular table. I won't get into the details. If someone wants to understand how it works, you can just pause the video and have a look at it, right? But what I'll do is I'll try to take a very simple example and try to basically break it down, right? I have three sentences over here. Let's take them as documents. And these three sentences are: I love deep learning and AI. AI is the future of deep learning, and deep learning is amazing, right? Now the word deep appears in all the three documents, right? If you have a look over here, it appears in all the three documents. So what happens is a lower IDF score would be assigned to this particular to the word deep, right? And because of this, right, this is in denominator, and because of this a lower IDF score would be assigned to this. Now what exactly is TF-IDF? It is multiplication of TF and IDF. Now even if the term frequency is very high, the IDF frequency is low because of the repetition, automatically the TF-IDF score gets penalized for the word deep in case of these three documents, right? And that's what happens over here. But if you look at the word amazing, now this amazing is only appearing in document number 3, right? And that's where you see that a higher IDF score would be given to the word amazing, and that's where it is more and that's where it becomes more unique and important, right? And therefore it gives a bump to the score of the word amazing itself, and that's how you can help it in that's how it helps the computer to focus on more important words like amazing instead of words like deep or the, right? So now, where exactly is this TF-IDF used in real life? So there are two examples. One is the search engine, Google, Bing. They use similar sort of an algorithm, which is also known as PageRank algorithm. Google it. It's quite interesting to understand about that as well. And then again, it is used for spam filtering and document categorization as well, right? But again, now, we had to move beyond the TF-IDF itself, right? Because it's still ignoring, number one, it's still ignoring the word meaning itself. Number two, it still struggles in synonyms and context. So for example, in the example that we saw over here, yes, deep might not be a stop word, but it's, I mean, by intuition, you can understand that it's a subject. The deep learning itself is a subject over here, right? And it's quite important for these documents itself. So that essence is not captured by the TF-IDF itself, right? And it is not dynamic for real-time learning itself. So this is where scientists came up with word embeddings like word-to-vec, doc-to-vec, and other word embeddings. We'll talk about these embeddings in the subsequent lectures. But this is where, finally the AI would be able to understand the the essence of the words itself, right? Where you will basically have embeddings which would be projected into, say, a 300 dimension vector space. And in this dimension you will learn, you will see that the vector representation of king is very close to the vector representation of something like queen, or you will see the difference between the vectors of the king and queen is very similar to the difference between the vector of a man and a woman, or something like that, right? So now you see that the embeddings models or the upcoming models were basically able to get essence of the words and represent it in a space which is much more meaningful than just using a TF-IDF or bag of word sort of algorithm. So yeah, we'll discuss the word embeddings in the next lecture, but share it with someone who might like this video. Thank you.